Good day, sir and classmates. So this is my report, bus and interconnection. 1. System bus. A system bus or in other term, internal bus is usually referred to as all signal that connect to a processor. A system bus is consists of three sub-bus system: address bus, data bus, and a control bus. So this is the address bus. The address bus is a computer or a series of lines connecting two or more devices that is used to specify a physical address. When a processor or DMA enabled the device needs to write or read to a memory location, it specifies that memory location on the address bus. The value to be read or written is sent to the data. Next is data bus. Data bus, a computer subsystem that allows for the transfer of data from one component to another on a motherboard or system board or between two computers. This can include transferring data to and from the memory or from the central processing unit or CPU to other components. Next is control bus. A control bus is what a computer's central processing unit or CPU uses to communicate with other devices inside the machine over a set of physical connections like cables or printed circuits. It is a diverse collection of signal including read, write, and interrupt which allow the CPU to direct and monitor what the different parts of computer are doing. Next is parallel and serial bus. Buses on motherboard are mostly parallel buses. A word of data can be read from memory at one time with one instruction. The industry standard bus or ISA and peripheral component interconnect or PCI, mini PCI and STD bus are parallel buses. So those are the parallel buses. PCI Express is a high-speed serial system bus that has 1 to 32-bit bus width. Next is serial communication and serial bus. This is contrast to parallel communication where several bits present as a whole on a link with several parallel channel. Serial communication issued for a long-haul communication and most computer networks where the cost of cable and synchronization difficulties make parallel communication impractical. Next is the Ethernet. Ethernet is very familiar to us. So Ethernet is a family of computer networking technologies for LANs or local area network commercially introduced in 1980. So the Ethernet is introduced in 1980. Ethernet has largely replaced competing wired LAN technologies. Systems communicating over Ethernet divide a stream of data into individual packets called frames. Next is interconnection buses. Computers with multiple processors located in a central location or distributed locations are generally considered as a parallel processing system. Here, multiple processors mean multiple processing units. A SISD computer is a Neumann machine built with a single processor. For MIMD system, each processor has its own cache memory. They also share the main memory, storage, and I/O devices, input or output devices in order to share data among the processors. Next is Frontside North Bridge. Frontside bus FSB functions as the process bus, memory bus, or system bus that connects the CPU with the main memory and L2 cache. FSB can range from 133 mHz to 400 mHz and up. In most cases, it is configurable via BIOS. Internal bus. An internal bus is a type of data data bus that only operates internally in a CPU, mostly between North Bridge and South Bridge. It carries data and operation similar to the FSB. Low pin count and South Bridge. Unlike FSB that provides fast connections with CPU, low pin count or LPC connects lower devices. It can be considered as substitute for ISA bus. Next is security considerations for computer buses. Computer system can be taken over from devices that are attached to the buses. The data stored on the computer can also be exposed to the programs or virtual machines that were booted from a USB memory attached to a computer USB port. In single bus systems, CPU and memory and input-output devices are connected to the system bus. So a compromised device can issue attacks on this computer system through interruption to stop processors from executing normal tasks. Dual bus interface design. A dual bus interface is a circuit that connects one or two buses. Next is to enable the device to be accessed simultaneously from those two buses. Being able to access from both buses at the same time is a key for a dual bus interface. So, example, an external DVD may have two or more buses, and that can be connected. This doesn't necessarily mean that it is dual bus enabled. We can choose to use USB or 1394 to connect a computer systems. Since normally we cannot connect both to buses to a computer system, therefore it is not a dual bus this device. So this is the last slide of my report. Thank you and God bless and stay safe.